Hi there everyone, welcome to the episode number 3 of this video tutorial series on academic illustrations. In today's episode, we will look into MATLAB. We will learn how to read data from external files, how to do some simple analysis of those data and create these kinds of illustrations for our academic reports. At first, let me just discuss briefly about the advantage and disadvantage of using MATLAB. I think right now MATLAB is one of the most popular tools for mathematical analysis and plotting for engineers, and so it has a very complete documentation, and because it has been around for such a long time, it has a very friendly and active user base. So if you find some problems while writing your own code, and if you can't find the correct examples in the documentation, there is a high possibility that someone in the forum has already faced that problem and the answer is already there. This has happened to me a number of times in the past few years. So I think this is one of the biggest advantage of using MATLAB, that it's really geared towards engineers. And so it is very easy to use if you are in some kind of engineering field. Okay. The second best thing about MATLAB for me is that it comes pre-packaged with a lot of useful libraries. As you can see, if I want to create a simple program for plotting, I really don't need to import any external libraries or any plugins. I can just start coding to read text files and then plot and manipulate that plot according to my necessities. The downside is that the installation file is quite large, but once I am done with the installation, then I'm good to go to write any kind of code that I want. It's very rare that I need to install any plugins or import external libraries. Okay, the third best thing for me is the workspace browser over here for MATLAB. It can be found usually on the right hand side beside the command window. This workspace browser is really useful for me because often I find that my code isn't running properly or there is something that I need to debug, and I can see all the variables from the workspace browser and the variables browser over here. So just by going into each of these values and understanding how they are being changed in my code lets me debug the code really easily, and it has been a great help. So for me, this feature is a very nice advantage of using MATLAB. Okay, those were the three that I wanted to discuss. There are plenty more, I'm sure, but those were the top 3 for me. The disadvantage of using MATLAB is definitely that it's not a free tool. You have to get the license yourself, or you can get it from your institution if they have an agreement with MathWorks. For me, I'm really lucky that my institution has this agreement, so I got the license from them. So please check out mathworks.com. If you can get the license from your institution, then that's the best case scenario. If not, then of course there are other tools. For example, we can use Python to do very similar stuff like this. That will be covered in the next episode. So if you are interested in learning Python, please check out episode 4 of this video tutorial series. Alright, with that said, I think we can actually go ahead and start discussing these examples. To save time, I have actually written down all of these examples beforehand. These are available for download. The links are in the video description. So please don't worry about pausing the video and then typing these yourself. Please follow the video from now till the end, and I think you will understand it clearly so that you can actually write it by yourself later by using the template. So let's start. The first command over here that I have written is close all. That's because I want to close any windows. For example, like this, if this figure is over here, it's active, then I can actually close it by writing close all over here, it got closed, or by writing the command at the top of my script. This is just closing that window. Alright, next one, I'm just setting up the value of voltage by using the linspace command in MATLAB. This linspace is just creating 21 data points from -1 to 1. Because the current value that I have written down, some random values over here, this is also 21 points. So I just wanted to create these two matrices for my example data. The function for plotting the graph is simply plot and then x and then y. So I'm plotting the voltage and current values with the labels of voltage and current density. If I am happy with this code, I'm just going to hit run over here, and this will be the plot that MATLAB gives me. It is quite okay. I don't like how small the axis labels are, and I would like to export this graph as a PNG or TIFF image. To do that, I will go over here to File and then Export. Over here, I can see that there are several options. In the size, I can actually choose the unit of my exported image. It's in inches, and auto is okay for now. In the rendering section, I can actually choose the resolution of my exported image, which I want to select 300 because 300 dpi is the usual resolution that journals are expecting us to create our images in. Then I would like to change the font. I think the font size of 18 would be much better. I will write down 18 and hit apply to figure. Now the figure looks much better already. And finally, over here, I can make this line a bit thicker by choosing the fixed line width of 1.5 points. Apply to figure. I notice that this line got thicker, but also the outside got thicker as well. Unfortunately, there is no way to change this one over here. We will have to modify this line in the code in the later examples. For now, I am happy with what I have got, so I will hit export. So MATLAB will give me options to choose either PNG file format or PDF or TIFF. I think TIFF is also available over here. And also MATLAB figure.fig format is available. If I save as MATLAB figure, then I can come back later and open this figure and modify the parameters again. If I don't save it as fig, if I choose as PNG, then of course it's going to be uneditable later. So I can choose, for example, figure just in case. And I can also export as PNG for my journal paper. I will hit OK, and let's check out how they look. So the plot is pretty good, and this plot, I think I can actually drag it, and then I can, oh no, I really can't open that one. I think I can open by File, Open. Yes, right. I actually never used that feature. I'm sorry about that. You had to see that now. Okay, so that's how you can actually save it as a MATLAB figure and modify later. All right, let's go on to example 1. Because the disadvantage of using this format is that if you hit run or F5 again, I just hit F5 on my keyboard, you have to do the whole process from the beginning one more time. For every image that you create, you have to change the export setup like this. So that is not very efficient. That is why in the example 1, this part is almost same. I just added this parameter of line width to be 2. Because I am writing this line width inside the plot function, only the plot line will get, the stroke will get thicker, the line width will be 2, the border will be 1 as always. So this is the only modification from example 1 up to this point. You can see, I'm sorry, you can see that there are a few lines over here. These are pretty easy to understand. GCA is something like a function inside MATLAB that is get current axis. So it will return an object. I am capturing this object over here using this name axis, and then this object has a few attributes. The attribute that I am changing is font name, font weight, and font size. I'm changing the font name to Arial. I'm changing the font weight to normal and the font size to 18. Okay. Next, this one is GCF, get current figure. This is also going to return an object. I am capturing that object in figure. I'm changing the parameter of paper unit to inches. I'm changing the position. This is something I found in the forums. This in effect means that this horizontal dimension will be 5 and the vertical dimension will be 4. That's all. So these two lines are just changing the figure into 5 inches wide and 4 inches tall. And I am printing, finally I'm printing the figure with the name of output. The format is going to PNG, and the resolution is going to be 300. So just by adding these lines, now if I run the code, I can see immediately the text has been modified, the line is much thicker, and automatically the output is over here. So I don't need to go to the export setup and then export this file manually. Every time I'm going to hit F5, it is going to create a file named output. So you can understand that if I change some of these values and hit F5, my original output image is going to be replaced. That is why please be careful. If you want to create a new image, you can change the name over here and then hit run. That way MATLAB will create another file for you. If you keep the name same and hit F5 every time with different sets of data, every time MATLAB is going to replace your original image file. So please be careful about that. Now that we know how to create the basic plots and how to export them, let us think about a more realistic situation. So usually our research data will not be available inside the code like this, but it will be available as an external text file or a special format file like this one that I have over here is l18.iv. It doesn't matter what the file format is. If it can be opened over here by using the MATLAB text editor, then it should have no problem opening it using the built-in functions. So there is of course a whole list of the files that can be read by using built-in functions in the documentation. So feel free to actually search over there. But basically, if it is written in text formats using Unicode, then MATLAB should have no problem opening it. Okay, so this is my style of opening external text files. I use the function fopen and then give it the name. This name is only the name is enough because my text file and my script is actually in the same folder. So that is the reason I can just give it the name. If they are in a different folder, then you have to mention the directory as well. That is again written in the documentation. So let me just take 1 minute discussing this point. In programming languages, it is very important to read the documentation very patiently. I think in principle, all computer programming languages are the same. Their fundamentals are the same. No matter if you are trying to learn C or MATLAB or Python or Java, you have to be patient while reading the documentation and writing your first 10 or 20 codes. Once you get hold of the basic idea, you can move on to a second or third programming language very, very easily. But if you don't spend the time to learn one single language properly, you will find it very difficult down the line while actually implementing some of the basic ideas of programming languages. So my style is that I go into the documentation and the forums and check out how other people are doing it, and then I write the code according to my research files, to my research data. This is my way of doing it. This is definitely not the only way. There may be much better ways. So I encourage you to actually go on to the forum and do it by yourself. in a better way if possible. Okay, so as I was saying, I give this function, this command of fopen, and then MATLAB returns me an object. I take that object in FID, some kind of variable. I give that variable to TextScan, and I tell TextScan that you have to read 4 floating point values, because this file contains 4 floating point values with a space in between. So this is the format with spaces in between %f. That is fine. What is this part over here? I can see that my file has 1, 2, 3, 4 lines of some kind of information, header lines, I would say. That is why I am also telling TextScan that please be careful, there are 4 lines of headers at the beginning. So please ignore these lines and then start the scanning. This TextScan will actually return some kind of matrix that I'm capturing over here with this name content. And then I'm closing the file, because it's always good idea to close, otherwise your RAM will get clogged up. Okay. So this content, I can actually check out how it looks like by double clicking over here in the workspace browser. And I can see that this is actually a matrix of column vectors. So content 1 has 21 values, content 2 has 21 values, 3 and 4 has 21 values each. Content 1 over here has 1 value. So if I want to get the voltage values from this column, then I have to write down content 1. So this is content 1 is not actually one value, it is a whole set of values, whole column vector of values. So this vector I am capturing with the name voltage, and I am capturing the second vector with the name of current. So this is why I discussed at the beginning that workspace browser is so useful. You can actually understand that this is actually not one value but a set of values. Okay, all right. So after this, I actually have arrived at this point that I have my voltage set of values and current set of values. So I will just use this very basic plotting function. If I hit run, I can see that it gives me the basic format of the plot, because I did not modify the font size and the font families. That I did in example 3. Okay, so over here I am reading the file, I am plotting the graph, and I am changing the axis and the figures. So there is some lines over here. I think I need to explain these as well. I think I made a mistake. This line should be over here. Okay, this is better. So what are these lines for? This one, I think you can already understand. This is the limit. If I need to change the limit of the y-axis, then I can use this function ylim, or I can change the limit of the x-axis by using xlim. And this one is setting the x tick values and the y tick values of the x and y-axis respectively. So I think it is easier if I show you guys what it actually does. You can see that right now the x-axis values are from -6 to 4. If I uncomment this part and actually give it -4 to 4 and hit F5, you can see now the x-axis has changed the limit from -4 to 4 voltages. So this is why I put this command over here, but right now in default MATLAB is doing a pretty good job, so I commented it out. And the x tick and y tick values, these tick values are pretty good, so I commented that out as well. Because this template file is you can download it from the video description, that is why I wrote down all of these. Please change these values if needed. Okay, so if you want to do any kind of mathematical analysis, that is pretty easy, because right now you have all the values as an vector as a vector or as an array. So you can do any kind of modification. Let me just quickly show you. If I want to change the values to absolute, then I can use this ABS function over here, this modifier, and then I can change this y scale to actually log, because for example, right now this is the output of a photo detector where the negative current values are not important and the logarithmic values are more appreciated. So just by changing the modifiers over here and applying different kinds of functions on the current and voltage values, you can do any kind of mathematical analysis that you want. You can find the slope. For example, I think this is over here. By using the polyfit function, you just need to pass the x and y values. So x will be voltage, y will be current, and you will get the polyfit parameters over here. So this is how you can read the external files, get the data, and then do any kind of modification or manipulation you want with it. So this is actually a basic rundown of the plot generating tools inside MATLAB. I hope you found it at least a little bit useful. If you have any questions, you have any problems that you faced with MATLAB previously, please let me know down in the comments. I will try my best to help. In the next episode, we will look into Python and learn how to read external files, create similar graphs and plots. All right. Thank you very much for watching this tutorial. See you guys next time.